Jai Hind everyone. I am Achintya Pandey, as a assistant professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Today I will discuss about concurrency control technique in transaction management system. Okay. So these all are the techniques. Before these techniques, let's see what type of executions are there. Okay. So we have linear execution, we have concurrent execution, we have parallel execution. So let's see the difference so that we know what are the concurrent process or concurrent transactions, how it's going to be processed. Okay. So say we have say linear execution, or sometimes it is called sequential execution, sometimes it is called serial execution, or okay. So there are three types of execution, three type process. One is serial or sequential, second is concurrent, and third one is parallel. Serial means say we have like three transactions, T1, T2 and T3 are there. Okay. So serial means once T1 completes, once suppose T1 consists of these 5 line or 6 line of operations, 6 line of instructions. Okay. So once T1 completes, then and only T2 start, then it is called serial or sequential executions, right? Until unless T1 doesn't complete, T2 cannot start, or you can say until unless T2 doesn't complete, T1 doesn't start. Then this type of execution is called serial. Concurrent execution, in actual practice, the process are running concurrently. Means there are overlap of execution. Means we can say like here we can say that like for example, if there are 6 line of 6 operations in T1 or T2 or T3 are there. Say let's suppose we have let's suppose 2 line of T1 or 2 instruction of transaction T1 execute. Then say for example 3 operations of T2 execute. Then suppose 4 operation of T3 execute. Then it's a let's say 1 instruction of transaction T2 execute. Then like this. So if these kind of sequence exist, means there are switching among the transaction, there are switching among the transactions, right? Switching means this could be switch from any point. At any operation it could switch to another transaction, or even sometimes it is called process, especially in the operating system it is called process. So in actual thousands of transactions are running over the system. Okay. So if the execution remains sequential or linear, it will be very, very slow. It goes very slow. It makes the system very slow. So serial execution is not solution for the speedy computations. Okay. So concurrent execution occur. Okay. So how we can control the concurrency so that the exact operation or correct operation be performed, it ensures the correct operations of transactions. Okay. So this is how. So we have the techniques, especially in used in the transaction managements. So there are many types of techniques, so that if the switching occurs and it resumes at the after some point, then the operations performed will be or the update which going to be there, update which transaction takes. They must follow all the property of transaction, like the basic property is acid property. So it must satisfy atomicity, consistency, isolation and durability. Okay. So we have these kind of rating which is used for concurrency control. so that the result ensure the correct, means every operations will correct evaluate the data items and all, right. So we have lock based protocol where lock is being introduced. We have time based protocol, we have validation based protocol, we have multiple granularity, and we have multi version schemes. In this video, I particularly explore the lock based protocol and little view of time based protocol. So what is the lock based protocol? Okay, so before lock based protocol, here two-phase locking protocol are used just for concurrency control. Let's see what is lock. So when lock is, where lock are used. So lock is basically used just to lock a data item. Suppose if any data item is going to update, so before that we lock that data item, so that if another transaction want to access that data, so they need to take permission from concurrency control manager. So if say one transaction locks a data item, so another transaction going to access that data item, they need to take permissions. Okay, so we have two types of locks. So wherever the data is going to update or even read, before that we lock that data item. That is the overview of the lock based method or protocols. So we lock that data item, the data item where it is going to update or even read, before that we must lock. Okay, so lock is a mechanism by which we can control the concurrency, or we can control the concurrent access of a data. Okay, data item can be locked in two mode. One is exclusive and second one is shared mode. So in exclusive mode, data item can be both read as well as write. Exclusive lock is denoted by lock X, while shared lock is denoted by lock S. So exclusive lock is requested using lock X instruction. Similarly, there is shared lock. Second type of lock is shared lock. So data item could only be read. Shared lock is used only the data item is read. Okay, but exclusive lock could be used for the read as well as write operations. Okay, so before say let's suppose a transaction consists of three data A, B and C. Okay, and that data is going to be say changed, or that data is going to update. Before that we lock that. So if the operation is going to perform write operations, so write operation must have exclusive lock, while read operations they could have flexibility of using both exclusive or shared lock. So lock requests are made to concurrency control manager by the programmer, and transaction can proceed only after request is granted. Okay, so this is how we going to use or control the concurrency. So let's explore. Let me explore some more point about different types of lock. So we have the lock compatibility matrix. If a transactions is if some say a previous transaction is already locking some data item, so whether the new transactions could access or could lock that data item or not. Okay, so a transaction may be granted a lock on an item if the requested lock is compatible with lock already held on item by another transaction. So any number of transaction can hold shared lock. Okay, n number of transaction can hold shared lock on an item. But if a transaction hold an exclusive on that item, then no other transaction may hold any lock on that item. So that is what, if there is a exclusive lock, say here exclusive lock is there, then we cannot even lock shared or exclusive. Say let's see the compatibility metric. If shared lock is true, then we can say that this another transactions would have true as well as false value. Okay, means shared true, it is okay, but shared exclusive is false. Similarly, exclusive shared is false and exclusive is also false. Meaning is that if there is a read operations, so read operations will follow shared log. So it could be true, while if some any data item is exclusive log, then on that data item another transaction is not allowed for either shared log or exclusive log. So if a log cannot granted, the requesting transaction is made to wait till all incompatible log held by other transaction have been released. Then lock is granted. Meaning is that if a data item is logged by some transaction, say T1, let's suppose data item A is being logged by transaction T1, and T2 transaction also want to access that data item. They cannot, because this data item particularly exclusive logged by the T1 transactions. So T2 transaction need to wait, because it will request to transaction control manager. Transaction control manager will see that this has been already logged by transaction T1. So until unless T1 doesn't release that log, T2 cannot T2 cannot use that data item. T2 cannot update that data item. Okay. Let's see here. So example of transaction performing locking. For example, say there is a data item A. So we have locked data item. I just shared logged. Then we are just going to perform read operation on that data item. Then we unlock A. After unlock, we could even use that data item, okay, by another transaction. Similarly, B data item is being shared log, then before the read operation. So before read write operation, we need to log first, and after that, after performing read, we have been unlocked and all. Okay. So unlocking protocol, basically it is a set of rules followed by all transaction while requesting and releasing locks. Okay. So locking protocol restrict the set of possible schedules. Okay. So what is the two-phase locking protocol? So we have discussed, what are lock, what are types of locks, and just based on that locks, there is a protocol that is called two-phase locking protocol. This is very, a good protocol for concurrency control manager. Okay. So two-phase locking protocol, it says that every transaction must have only two phase, not more than that. Okay. And the transaction or where the data item taking locks, that phase is called growing phase. And where the transactions, you can say if transaction unlocks data items are, that phase is called shrinking phase. So where the data items are going to lock, that phase is called growing phase. Okay. And shrinking means unlocking that data item, that phase is called shrinking phase. So if a transaction follow only two phase, growing and shrinking, it could not be like growing, shrinking, then it will violate the two phase locking protocol. So if a transaction or set of transaction follow just two phase, growing and followed by shrinking, then and only we can say that it is the it ensure the concurrency. Okay, or it ensure the serializability, because if concurrent executions or concurrent transactions, if we can make concurrent transactions as some kind of serializable schedule, like conflict serializable schedule or view serializable schedule, then and only it ensure that all the operation been updated or performed will be the correct. Okay. So two-phase locking protocol say that it has two phase and every transaction must follow only these two phase, not like growing, shrinking or growing, shrinking. Okay. Like here you can say that here A is going to lock, so this phase is called growing phase. Okay, this is A is unlocking, so this phase is called shrinking phase. Similarly, B is locking, so here it will be growing phase. Similarly, B is unlocking, so this will become the shrinking phase. So if it is a sequence of the operation of, say, for example, this T2 transaction, so this is definitely avoiding the two-phase locking protocol, 2PL protocol, because it has growing, shrinking, growing, shrinking. So this should not be the case in two-phase locking protocol. So if our transactions follow two-phase locking protocol, then it would have only just two phase: growing, where transaction takes all lock; shrinking, where transaction release all lock. So somehow, if we want to make it as or it should follow what two-phase locking protocol, we simply either shift or change the order of unlock. If we just shift the unlock here or even here, so it will follow the two-phase locking protocol. Why? Because we have simply locked data item A, so this become the growing phase. Again, we have locked data item B, so it remains in the growing phase. So up to this point, this will have growing phase, and from here we are going to unlock A, then unlock B, or even unlock B, unlock A. So this become the shrinking phase. So just shifting or reordering the locking and unlocking or transactions could be made into two-phase locking protocol. So if our transactions follow two-phase locking protocol, then it will be some kind of, the transaction will be into some kind of conflict serializable. The schedule become the serializable. Once the schedule become the serializable, all the operations performed will have the correct result. Okay. Okay. So this is what two-phase locking protocol is. So the protocol assure serializability. It can be proved that the transaction can be serialized in the order of their lock points. Okay. Okay. However, there is a problem associated with the two-phase locking protocol. Two-phase locking protocol never guarantee that deadlock cannot be occur. This is the limitation, or you can say a drawback of two-phase locking protocol. It doesn't ensure deadlock free. Okay. So we will see the example. So there can be conflict serializable schedule that cannot be obtained if two-phase locking is used, however, in the absence of extra information. So this is what. Let's see the example, this one. If execution sequence follow like these operations mentioned here, so we will see either here it is deadlocked. I mean we have two-phase locking protocol, but it has been come into the deadlock. For example, if sequence like this, so here we have locked the data item B, so this become the growing phase, and then we have read operation are there. B is being updated. Okay, write B. So B is being logged, and here again B, you are going to lock B. So after that you cannot move on. I mean the instruction below that you cannot, because B is already logged. So this lock cannot be, I mean concurrency control manager will not give the permission to that to access below that. Okay, because B is already logged by transaction T3. Similarly, here we can say that A is logged by transaction T4. Okay, A is logged by transaction T4, and once it follow and come into T3 transaction, A is further been exclusive logged. So this will not execute. I mean they cannot go below that because it is already logged by T4 transaction. So after that no instruction will be executed here. After that T4 will not execute any more instructions. So somehow T3 and T4 could not proceed further. Okay. So they are being logged. Okay. So by making here we need to take care of sequencing or ordering of locking and locking sequence, because the sequence may lead to deadlock situations or starvation situations. Okay. So such a situation is called a deadlock. So this is one of the drawback of two-phase locking protocol. This two-phase locking protocol doesn't ensure the deadlock free transactions. So to overcome this, we have another technique that is called timestamp based protocol, and there we associate the timestamp with transaction as well the timestamp with the data items. So that protocol overcome the deadlock free executions. Okay. So this is the implementation of locking, how we are going to implement these kind of concept. So we have a lock manager that can be implemented as a separate process to which transactions send lock and unlock request. Okay. So the lock manager replies to a lock request by sending a lock grant message or a message asking the transaction to roll back in case if there is a deadlock. The requesting transaction waits until its request is answered. So until and unless transaction control doesn't allow, they will not execute the instruction forward afterward. Okay. So the lock manager maintain basically a data structure that is called lock table to record granted lock and pending requests. Okay. So the lock table is usually implemented as in a memory hash table index on the name of the data item being logged. Okay. So we already know if there is a deadlock, so we have deadlock handling technique, and the techniques are which we used to overcome the deadlock. We have deadlock prevention and we have deadlock avoidance. So by using deadlock prevention or deadlock avoidance, we may overcome the deadlock free transactions. Okay. We also use wait for a graph. If in wait for a graph there is no cycle, then we can say that these transactions will be out of deadlock. Okay. So by that way, next techniques we have multiple granularity, where we allow data item to be of various sizes and define a hierarchy of data granularity, where the small granularities are nested within the larger ones. So these all are some different techniques to control the concurrency and access. Okay. There we have, in addition to exclusive lock and shared lock, we have intention shared and intention exclusive lock. Similarly, these all are the compatible metrics for all locks. Okay. So this is what a brief of this concurrency control techniques, particularly the two-phase locking protocol. So the conclusion of the two-phase locking protocol is that if every transaction follow only two-phase growing and shrinking, then and only it becomes the conflict serializable or some kind of serializable. So two-phase locking protocol ensure the conflict serializability, but it doesn't ensure the deadlock free executions. So to overcome, we have some other techniques like timestamp protocol. In that we do not have kind of deadlock transactions. So that we could avoid. Okay. So this is all for the concurrency control technique. Thank you very much.